Everyone thinks Optimus is Tesla's biggest invention. That is the story you already believe, the one built from headlines and stage demos and a walking robot doing a little dance in front of cameras. But what if that is the wrong story entirely? What if the real breakthrough is not the robot at all, but the factory that robot quietly makes possible? Stick with me for the next few minutes, because by the end of this, you may never look at that humanoid robot the same way again. This is not a review of Optimus. This is an investigation into what Tesla might actually be building behind it. Here is the uncomfortable question nobody in the mainstream coverage seems to be asking. Why does a car company need a humanoid robot in the first place? The obvious answer is that Optimus will fold laundry or walk your dog someday. But that answer does not survive contact with what Tesla itself has been saying quietly in earnings calls and engineering updates and factory announcements that most viewers scrolled straight past. Tesla's own public materials frame Optimus not as a standalone consumer gadget, but as one piece of a much larger autonomy and robotics push, sitting right alongside self-driving cars and industrial software. That framing matters more than it sounds. It means the robot was never meant to be the destination. It was meant to be the delivery vehicle for something bigger, an entry point into a system that touches assembly lines, logistics, inspection, and maintenance all at once. So let us find the golden fact, the detail almost nobody is talking about. Reporting tied to Tesla says the company is repurposing production space at its Fremont facility, the same Fremont that has spent almost 2 decades building cars, and converting part of it into Optimus manufacturing. Musk himself has reportedly floated a target of up to 1 million Optimus units per year out of that single site, with even larger ambitions mentioned elsewhere. Think about the scale of that number for a second. 1 million humanoid robots a year is not a hobby project. That is an industrial commitment on the same order as building a new category of vehicle from scratch. And here is where the story stops being about a robot and starts being about a machine that builds machines. Because a factory capable of producing 1 million robots annually is not just a bigger assembly line. It is a factory that has to rethink itself, using automation to build automation, using AI to supervise AI, using robots to manufacture the very robots meant to replace bottlenecks on that same floor. That is the loop. That is the golden fact hiding in plain sight, and it is the thread this entire documentary is going to pull. What if the real breakthrough is not the robot at all, but the factory the robot makes possible? Let us sit with that thesis for a moment, because it reframes everything that follows. If Optimus is just a product, then Tesla is a robotics company competing with Boston Dynamics and Figure AI and Apptronik for humanoid market share. But if Optimus is a component, a tool inside a bigger operating system for manufacturing itself, then Tesla is playing an entirely different game. One closer to what Siemens and Nvidia have been building for years with industrial software and digital twins. This is where things get genuinely strange, because the pieces have been sitting out in the open the whole time, scattered across earnings calls, industry conferences, and engineering blog posts, and almost nobody has connected them into a single picture. So let us connect them now, one by one. Start with digital twins. Siemens has spent years describing digital twins as living, evolving models of a factory. A virtual copy that can be simulated, stress-tested, and optimized before a single physical change ever hits the real production floor. Picture designing an entire assembly line inside a video game first, running it through 1,000 failure scenarios overnight, and only building the version that survived all of them. Siemens and Nvidia have already been pitching exactly that combination: virtual commissioning and synthetic data generation as the backbone of the next generation of factories. Tesla has not published the full architecture of its own factory twin stack, and that silence is worth noting, but its public direction points the same way: an AI-first manufacturing philosophy where the robot and the production ramp get the headlines, while the software underneath stays deliberately unglamorous. Compared to Siemens, Tesla talks less about architecture and more about output. More robots, more capacity, more scale. That is a strategic choice, not an accident. Now add autonomous logistics into the mix. A humanoid robot that can move boxes, load stations, and transport parts across a factory floor is solving one of the most expensive, most stubborn problems in manufacturing: the physical movement of materials between fixed machines that were never designed to talk to each other. Reporting tied to Tesla already describes Optimus operating on live factory floors, handling exactly these kinds of tasks: moving parts, performing visual inspection, filling in the gaps that fixed robotic arms simply cannot reach. That detail alone should stop you for a second, because fixed industrial arms from companies like ABB, Fanuc, and KUKA have dominated factories for decades precisely because they are fast, precise, and reliable, bolted to one spot doing one motion forever. Their weakness has always been flexibility. They cannot walk over to a different station. They cannot adapt to a reorganized floor plan. They cannot substitute for a missing worker on a night shift. A humanoid robot, however slow or expensive today, solves that flexibility problem in a way fixed automation structurally cannot. Now add quality inspection. A robot with vision systems and consistent attention does not get tired at hour 10 of a shift the way a human inspector does. Add predictive maintenance. Robots that can access tight spaces, check on equipment, and flag problems before a breakdown halts an entire line. Each of these capabilities sounds small in isolation. A minor feature update, a demo clip, a press release nobody remembers a week later. But stack them together. Robot mobility, inspection, maintenance access, logistics, and you are no longer describing a robot. You are describing the nervous system of an autonomous factory. This is the pattern this documentary wants you to see clearly. Every new Optimus capability announced over the past year was never really about the robot getting smarter for its own sake. It was another wire connecting the same nervous system, another sensor feeding the same loop, another step toward a factory that can watch itself, correct itself, and improve itself with less and less human intervention required at every stage. So why would a company built on cars pivot this hard into manufacturing infrastructure? Because the profit logic is different and arguably better. Selling cars means competing on razor-thin margins against every major automaker on Earth, including BYD, which has become a genuinely formidable rival in both cost and scale. Selling an entire manufacturing operating system, the software, the robots, the digital twin, the whole integrated loop, means selling infrastructure that other companies would have to license or replicate at enormous cost. One is a product business, the other is a platform business. Platforms tend to win bigger and longer. Consider the capital being thrown at this bet. Coverage of Tesla's 2026 first quarter earnings reference more than $25 billion in planned capital expenditure for the year, a staggering figure aimed substantially at AI and robotics infrastructure. $25 billion is not pocket change directed at a side project. That is the kind of number a company commits when it believes it is building the foundation of its next core business, not a quirky accessory to its old one. Now widen the lens to the rest of the industry, because Tesla is not operating in a vacuum here. ABB, Fanuc, KUKA, and Rockwell Automation have spent decades perfecting pieces of this puzzle: precision robotic arms, industrial control systems, factory floor automation software. Siemens and NVIDIA have been building the digital twin and simulation layer, virtual commissioning environments where entire production lines can be tested before they physically exist. Boston Dynamics, Figure AI, and Apptronik are racing Tesla directly in humanoid robotics, each betting that walking, dexterous machines are the next frontier. Here is the distinction that actually matters, and it is the second insight this documentary wants you to sit with. Every one of those companies is extremely good at solving one piece of the puzzle. Siemens owns simulation. ABB and Fanuc own precision arms. Figure AI and Boston Dynamics are chasing robot dexterity. NVIDIA owns the compute and the synthetic data pipeline. Nobody else on that list is simultaneously designing the robot, manufacturing the robot at industrial scale, deploying it on their own factory floor, and feeding the resulting real-world data straight back into the next generation of robots and software. Tesla, whether by design or by necessity, appears to be the only player attempting the entire closed loop at once. That closed loop is the second thing nobody is talking about, and it deserves its own moment of attention. Robot design informs manufacturing. Manufacturing generates factory floor data. Factory floor data trains better robots and better factory software. Better robots and software improve the next manufacturing run. Round and round it goes, each cycle theoretically cheaper and smarter than the last. If that loop actually closes at scale, Tesla stops looking like a car company with a robotic side project and starts looking like a vertically integrated industrial platform with cars as merely its oldest product line. So the robot was never the real story. Let that sink in for a second, because it changes how you should read every future Optimus announcement. The next time Tesla shows off a slightly more dexterous hand or a slightly smoother walk, the interesting question is not how impressive the robot looks on stage. The interesting question is what factory process that improvement is quietly designed to unlock. Now, before this goes any further, the responsible thing to do is separate what is actually verified verified from what is still speculation, because overclaiming here would be exactly the kind of mistake that hands ammunition to skeptics. So here is the honest ledger. Verified fact, publicly available and confirmed. Tesla positions Optimus as part of a broader autonomy and robotics strategy, not a standalone consumer product. Reporting tied to Tesla says Fremont production space is being repurposed specifically for robot manufacturing. Siemens publicly describes digital twins as tools that can model factories, optimize operations, and generate synthetic training data for autonomous robots. Company statement, meaning Tesla's own words, not independently verified beyond the statement itself. Tesla describes Optimus as intended for repetitive, boring, or unsafe tasks, framed inside a wider autonomy push. Reporting tied to Tesla quotes Musk explicitly tying Fremont capacity to Optimus production at scale. Industry consensus, broadly shared across the sector rather than specific to one company. Factory digitalization, industrial AI, and simulation-based planning are becoming steadily more important across manufacturing, particularly for complex and constantly changing production environments. Robots remain most immediately useful in repetitive or semi-structured industrial tasks rather than fully unstructured ones. Expert opinion, meaning informed perspective rather than settled fact. Industrial software leaders increasingly talk about treating the entire factory as a product in itself, something to be continuously redesigned and optimized rather than built once and left alone. That view supports the idea that the surrounding factory system may ultimately matter more than any single robot inside it. And finally, speculation, clearly labeled as such. The idea that Tesla becomes the world's first true AI-native factory system company is plausible given the pieces in motion, but it remains unproven. The claim that Optimus will rapidly transform manufacturing across the entire industry within the next few years is still an open question that depends heavily on execution, not intention. Because here's the part the hype cycle conveniently skips over. Musk himself has reportedly called scaling Optimus the hardest manufacturing challenge Tesla has ever taken on, precisely because almost every component on the robot is new, unproven, and untested at true industrial volume. That is not marketing spin, that is closer to an admission. Dexterity remains difficult, battery endurance remains a real constraint, cost per unit remains unclear at meaningful scale. Safety certification for humanoid robots working alongside human employees is still an evolving regulatory landscape, and reliability in messy, unstructured, real-world factory conditions, the conditions machines have historically struggled with the most, is still very much unproven at the volumes Tesla is reportedly targeting. So here is the provocative question worth sitting with, the one worth leaving in the comments below. If Tesla actually pulls off this closed loop, robot design feeding manufacturing, manufacturing feeding data, data feeding better robots and better software, does the humanoid robot even remain the interesting part of the story 5 years from now? Or does Optimus simply become one component among many, quietly working the night shift inside a factory that increasingly runs itself? And if that is where this is heading, should we still be calling Tesla a car company at all? Or is that label already several years out of date? Because here is the closing thought worth carrying with you after this video ends. The evidence gathered here does not prove Tesla has already built a self-improving AI-native factory. What it does show is a company placing an enormous, well-funded bet that the biggest prize in the next decade of manufacturing will not go to whoever builds the best individual robot. It will go to whoever builds the best system the robot lives inside. The real product Tesla may be building is not Optimus. It may be the world's first AI-native factory, with the humanoid robot simply serving as its most visible, most photogenic employee. Whether that bet pays off is still an open question, and one worth watching closely over the next few product cycles, not just the next few demo videos. To not get caught off guard by what is coming next in this industry, whether it touches the car sitting in your own garage or the entire manufacturing world behind it, join us here at Driven to Distraction, because the next chapter of this story is probably not going to arrive wrapped in a walking robot. It is going to arrive quietly, inside a factory nobody was watching closely enough.